This is project 5, video number 2, the one in which we coded up. Let's see, I'm supposed to find an electric field X component. I think I'll call it get E sub X. Please call it something else. So come up with a name, but make sure that you save your file as your function name .m. So I haven't got this fixed up yet. So function, and then return variable. I think I called it ex total equals my function name. I'm calling it get E sub X. So again, use a little imagination, creativity, call it something other than ex total, but make it so that it tells the reader what you're doing. Don't just call it my project 5 return variable or something like that. So make it self-documenting. Make your program self-documenting. That is, choose variable names and function names that tell the reader what's going on, but don't just copy mine. X comma Y. And then that's an end for the function, and tab to indent for the function statements. Function return variable is ex total. It's equal to function name get ex x comma y. That looks good. Now let's do. I remember I was going to say k equals 8.99 e times 10 to the 9th. That's the Coulomb constant, and then I think it was x equals linspace. I wanted to play with that a little bit, make sure that I had linspace right. So let's try linspace. I'm going to go 0, 1. Say I want 10 values. No, I want 11 values. And that should give me, yeah, okay, so I had the right idea on that. So go to the editor, linspace. I need to go from 1 centimeter, that's 0.01 meters, up to 1 meter. And I want 100 steps. Alright, that should be perfect. And then Q. Pretty sure. Let's check and make sure I had a nice outline going here. Get X, P, and YP. I think I want to be careful to make that distinction. I'm going to call it XP and YP. Again, you get to choose what you're going to use for argument variables. This is, I like mine actually. XP, X capital P, is the X coordinate of point P, and YP is the Y coordinate of point P. Alright, so what else did I have in my outline? Q 1.01. I like to copy and paste that. Alright. 1.01 minus 1.0 times x, except this was times 10 to the minus 6 coulombs, and this is 1 times 10 to the minus 6 coulombs per meter. Alright. Let's save that. Get EX in that lab. I think I'm in the right location too. Let's see if I'm not seeing it there, so. Oh, there it is. Get ex dot m. Alright. So then q is equal to that. It's just a number times those 100 values, so I don't need a dot star instead of the star. But, oops, I wanted to look at what comes next. So then get an array of the r values, xp minus x in there. Alright. So my r array equals square root of x minus xp dot to the power of 2 plus, I'm going to just add a little extra space, make it easier for a person to read, y to the power of 2, close the parentheses for the square root. I got the dot power for this because the quantity in parentheses is an array. I want to erase each element. I want to do it element by element. Find out what R1 is and find out what R2 is, etc. As opposed to some matrix operation. MATLAB stands for Matrix Laboratory, so it tends to assume things are matrices. Alright, next. Where'd you go? There it is. I'm already up to calculating e sub x. That's cool. E sub x is kq x over r cubed. Roughly, it's a difference of x's. So ex, this again, an array of values, is equal to k times q times x minus xp divided by r to the power of 3. I'm forgetting some semicolons, and then I have to worry about, alright, r is an array, so I want to raise it to each element to the power of 3. I'm dividing by an array, so I gotta divide by each element of the array. And then up top, this is an array times an array. So I think I'll be finding out what this array is, then multiplying it times just a single value, so I don't think I need a dot there. So it's just star there, because all I'm doing is multiplying by k. If that doesn't work, I can put a dot in. That's a dot star, because it is an array times an array. And then dot slash, it's an array divided by an array, and then dot to the power. Dot power. Alright, ex total, which is my return variable. I think, I'm not sure why it's highlighted here but not there. Oh, there it is. Okay, equals sum of all the ex's. All this does, I got an array of 100 values. It's like a list of 100 values. All this does is add up all the elements of the list, all the elements of the array. I'm going to put a semicolon there, and I think I should be good. I'm not sure why this is highlighted. But get ex of xp comma yp. I think this is looking pretty good. Let's try saving it. Let's try running it. Get e sub x of let's go, it's supposed to be greater than 1 meter. Let's go 1.1 comma 0.1. So I expect it to be positive. The e sub x is to the right at that location, and I would think kind of big because I'm pretty close to it. Oh yeah, I did mean that. Thank you. Undefined function or variable y. So I think yeah, that's supposed to be a yp. Oh, you are so kind to tell me what my mistake is. Thank you, MATLAB. Alright, control. Oh, that's why. It was saying I hadn't used that variable. So I should have known right then. It was already trying to tell me something was wrong. Alright, let's try running it again. Up arrow. And run. And it gives me a number. Except it gives me a negative number. And I was expecting something positive. The x component of the electric field is positive. And I think I can see the issue up here. Oh no, that's good. Now xp is greater than x, so I should be having xp minus x everywhere, not the other way around. That shouldn't matter here. xp minus x. I want to try saving that. I want to look at this, see if we can fix anything up in there. Yeah, I had xp minus x there. This was supposed to be a p right there. So I think I had added that. You know, I had two different x's defined. I had x defined with two different meanings. And I changed one of them to an xp, but I didn't change it everywhere. So this is xp. Well, I don't know that I got to change it there, but I got to change it in the coding. Up there I was using x divided. Say I was talking about the ith one, and I called the coordinates point P x and y, but I switched over when I was doing the coding. My x was had all 100 of my x sub i's in it as the whole array, and so I needed xp, but xp minus xi, I had it right in the pencil and paper part, although there was one subscript missing. Let's save that. Then I go back over to here. I think I've already fixed it up. Control S. See if we can run it again. And now I'm getting a positive value. Make a couple of little common sense checks. If I go up higher, then the x component should be less. So I'm going to go up to say 0.2. I get a smaller x component. Good. If I go farther over to the right, I'm getting farther away from my distribution of charges. It should get smaller as well. It went from 9.55 down to 7.3 times 10 to the fifth in both cases. I think if I get right on the x-axis, this thing wasn't really supposed to be, I said it was supposed to be good for y greater than 0, but I can still test it out. I'm going to go 1.1. So, just to the right, it seems like, yeah, the x component should be greater. You get 1.4 times 10 to the minus 6. Yeah, before I had 1.2 times 10 to the... Well, I think I said minus 6, but I meant plus 6. So 1.4 times 10 to the 6, which is indeed greater than 1.2 times 10 to the 6. Alright, so passes a few common sense checks. I haven't really given it a thorough testing, but I think I'll just take another look. Make sure it makes sense. I did at least remember to take the x component of it before I added stuff together, so it'd be sinful to just add the magnitudes of the electric field, because the electric field vectors, because that's not how vectors add. But this has the right units. KQ over R squared has the units of E, and then this is got those same units because I got a distance here divided by a distance cubed is the same thing as just 1 over distance cubed. So that's KQ times 1 over distance cubed, which is an electric field. So the units look good. And I guess it wouldn't hurt to print some stuff out. I think Control S, saved it, and run it, and the X values indeed are going 0.01 meter, 0.02 meters, so it's going up by a centimeter all the way up to 1 meter. So it was supposed to go from 1 centimeter to 100 centimeters, so that looks good. Then the Q's should be getting smaller and smaller the bigger we go. So the last one is the smallest, according to the formula that they gave. Q, 1 times 10 to the minus 6, starts out at 1, and then drops down steadily. In a linear fashion, actually, down to 0.01. I think that makes sense from the original formula given. That does make sense. And then the R's, with what I got, it getting smaller and smaller. With the position I'm running this at, the R should be getting smaller and smaller. So point P is just to the right of the last point, so the later points are closer. Let's try running that. And what are the R's doing? So there's R. Starts at 1.09, it's decreasing, continually decreasing. Yeah, so that makes sense. And then E sub x. Let's see what the values in there look like compared to my total. They should all be smaller than the total because they're all positive. So I'm supposedly adding up a bunch of positive numbers. And let's see if there's a times 10 to the 4 up there. Point. Yeah, it goes from below 1 to above 1. This is kind of interesting, these electric field values seem to be getting bigger for a while, and then they get smaller. So 0.3. I think the power of 10 has changed. So 2.01, 2.01, they're getting bigger, and then 2.4903, 2.4972, and then it gets smaller. So let's see where I'm calculating. Maybe we've this debugging has helped out. What was I said at 1.1 comma 0. Oh, I know what's going on. I got the separation is getting smaller, but the charge is getting smaller too. So let's see if it makes sense that it would get smaller toward the end there. The separation is getting smaller. Okay, I guess I don't see it for sure, but it is interesting. And we get the R goes like an R cubed, and yeah, I think at first what matters most is that the charges, the particles are getting closer. Yeah, the particle that we're looking at is closer and closer to point P. But so even though the amount of charge that it has is decreasing, it's the closeness that is the more important factor. And then as we get close to the end, the amount of charge becomes an important factor. I mean, we're getting close to 0 charge toward the end. One more step and we'd have 0 charge. So that's mildly surprising for me, but it's not an indication that we've got a mistake there. Alright, so just something that I think turns out interesting for this problem. Although, admittedly, we weren't even supposed to be calculating it at that location. The thing is, I could go, point 1, 2, 3, 4, 5 zeros and a 1. We are supposed to be able to calculate it there, and it would come out at about, comes out the same to 5 sig figs. So, and we would see the same variation in the E itself. But we were in the 10 to the 4 ballpark, but we're adding up 100 of them. 100 times 10 to the 4 is 10 to the 6, so it does make sense that we added them all up and we got something in the ballpark of 10 to the 6 when each one of those was something times 10 to the 4th, or around 1 times 10 to the 4th. So I think I'm going to call that a wrap for project 5, video number 2. Oh, actually, let me run it one more time. I'm going to cancel that. I want to make sure that that I save the latest version, and it is running, and it's not printing out anything that it's not supposed to. In fact, if I put a semicolon afterwards, it prints out nothing. It's just returning that one variable. Note, if I wanted to assign that variable to something, I could type in myvar equals whatever that function returns, and then I see myvar. If I just type myvar in, I see that myvar has that value. So it's working perfectly. Okay, now I'm going to call it the end for project 5, video number 2.